Hello, welcome to section 3.3, which deals with finding the equation of a line. And there are a bunch of ways to do that. So let's get into it. We're going to do first, given the slope and the y-intercept. That one's really easy because you remember that the formula for slope, a formula for equation of a line where it shows the slope and the y-intercept is this y equals mx plus b. If you're not familiar, get familiar because you're going to see it a lot. So if they give you this, find the equation of a line with slope -7, that's right away telling you, hey, m is equal to -7 and y-intercept 0, -1. That means that the value of b is going to be -1. So all you have to do is just plug this into here and this guy into here. So you're just substituting. So it's very easy. So -7x minus 1, and that's it. So then for the next one, slope is 2/5. Y-intercept is 0, 4. In other words, the value of b is 4. So y equal mx plus b. All right. So that's nice. What if we have just a graph and we want to find the equation of the line? So we need to figure out what the y-intercept is and then what the slope is. Okay, so the y-intercept is right here, -4. The slope is, we can count from here going up 2 and over 3. So the slope is 2/3 positive, okay? So then the equation is just going to be 2/3 x minus 4, and we're done, okay? Let's do another one. Here, the y-intercept is 1, so b equals 1. And then the slope, let's get to this other point here. So we go up 3 and to the right 5. 1, 2, 3, 4, 5, yeah. So the slope is 3/5. So y equals 3/5 x plus 1. Okay, not too bad. Now let's introduce this point slope form of an equation of a line because we don't always have the graph. And sometimes they're going to give you not the y-intercept, but they're just going to give you like an arbitrary point that's on the line and the slope. And we can use this equation to solve for, to find the equation of a line. You can use this formula to find the equation of a line given the slope and a point. Okay, so best thing to do is just let's start doing some. Okay, point slope formula is y minus y1 is equal to m times x minus x1. Okay, so we just need to identify stuff. So here's my m. Okay, fine. And it contains this point x1, y1. So all we have to do is plug stuff in, okay? So y minus 3 is equal to 2/5 times the quantity x minus 10. Now it wants the equation in slope-intercept form. And what is that? Y equal mx plus b. Okay, so let's go ahead and distribute this. We get y minus 3 is equal to 2/5 x minus, and then 2/5 times 10, which is going to be 4. But let me show you why. So 2/5 times 10 over 1. 5 goes into 10 twice. 2 times 2 is 4. So we get basically y minus 3 equals 2/5 x minus 4. Then add 3 to both sides because we wanted it to y equal mx plus b form minus 1. And there that is. Okay, let's do another one for funsies. Okay, so we have here m and the point. We're using point slope formula because we have a point and a slope. So this is x1, y1. Okay, so y minus, and then y1 is -4, equals m, which is -1/3. I'm assuming that's a 1, times the quantity x minus 6. Okay, so we distribute this guy. We get y plus 4 is equal to -1/3 x plus, and then 1/3 of 6 is 2. Then subtract 4 from both sides, and final answer, y is equal to -1/3 x minus 2. And that's it for that one. What if we want a horizontal line that has this point? Well, remember a horizontal line? It just is y equals a value, right? The horizontal line is like y equals whatever it is that, you know, the number is, where it intersects here. So here, the y value is 2. So the equation of a horizontal line would just be y equals 2. And that's it. All right. That is slope-intercept form because there's no slope is 0. So that would be, if I had to write that in, I would write 0x plus 2 if you want. Okay, so same thing here. Find the equation. That's just y equals 4. You know, because it's horizontal. That's the giveaway. If it was vertical, what would our equation look like? If you said x equals something, then you are in a good spot. Okay, what if I just have 2 points and I want to find the equation of a line? Okay, so that's also very possible. So what we need to do is use those 2 points, find the slope, and then pick one of the points and put it into point slope formula, and there we go. Okay, so it's just like we've been doing. So this is x1, y1. This is x2, y2. So first, let's find the slope, change in y over change in x, right? So that's going to be 2 over negative 2, so that's negative 1. So now we have the slope. And let's pick a point. I'll just pick this first one. So point slope formula says y minus 4 is equal to m. So let's write that y minus y1 is equal to m times x minus x1. So then negative 1 times the quantity x minus 5. Okay, so we're not done yet because the equation has to be in what form? Slope-intercept form. So we need to distribute this. So we get y minus 4 is equal to negative x plus 5. So then solving for y, we get y is equal to negative x plus 9, and we're done. Okay. Let's see here. I think we can do one more. Or I think that's, okay, we'll do one more. Find the equation of a line that contains these points. This is actually pretty much the same thing, so I'm going to delete this so I can have more space. Okay, so we have points x1, y1, and their second point, x2, y2. So the slope, change in y, remember to put in parentheses if you're subtracting a negative, over change in x. Okay, so if you write the parentheses, it's very easy to see. When you subtract a negative, it's the same as adding. Why? Because the opposite of a negative is a positive, okay? So this becomes negative 3 plus 4, and then down here, 1 plus 2. So we get on the top 1/3. Okay, so now I have my slope. Choosing either one, I'm going to choose this one. What's my formula? I'm using point slope formula. Why? Because I have a point and I have a slope, so I'm going to use the point slope formula. Okay, so math, at this point, it's very cut and dry. The name of the formula gives you, what you need to know to find the equation. So let's go ahead and plug everything in. We get y minus a negative 4 is equal to, what's my m? That's 1/3 times the quantity x minus a negative 2. Okay, so then all we have to do is just simplify here. We get y plus 4 is equal to 1/3 times the quantity x plus 2. Distribution property, y plus 4 is equal to 1/3 x plus 2 times 1/3 is the same as 2/3. Okay, then we solve for y. So y is equal to 1/3 x. And then for those of you that are scared of fractions, don't be scared of fractions. Firstly, don't be afraid of fractions. Secondly, remember you can always write a whole number over 1, and then you do common denominator like so. Okay, so it's going to be 2 minus 2/3 minus 12/3. It's going to be negative 10/3. Okay, so minus 10/3, and we're done. Okay. All right, let's talk a little bit about, before I talk about parallel lines, if you have the slope and the y-intercept, in order to find the equation of a line, you just plug that into the slope-intercept formula. Which one is the slope-intercept formula? It's the formula that you can obviously see where the slope and the intercept is. That's y equal mx plus b. If you have a slope and a point, you need to use point slope formula because you have a point and a slope. And the point is not necessarily the y-intercept. It's just an arbitrary point that's on the line, okay? If you have 2 points, you have to do a little bit more work because you have to find the slope first, and then you go ahead and use that slope that you've calculated and one of the points and put it into point slope formula, and there you go. Okay, so so that's that. So now we need to find, what if you have a line and they say, hey, I want you to find the equation of a line that's parallel to this given line that goes through a point. All that is, it might sound a little confusing. All it is, hey, we know that parallel lines have the same slope, So that's just another way of telling you the slope of your new line is this, okay? So let me show you what I'm talking about here. Okay, so first, let's make sure, we've talked about parallel lines before. Parallel lines are two lines that are in a plane. They share a plane and they never, ever, ever, ever intersect. They never touch. How do we know that they never touch? They have the same slope. They behave the same way. They do not deviate. So if you see here, we can check this. Here's two parallel lines. I can check the slope, right? Rise over run. So this slope here is 2/5. And then here I have another same thing, slope. As you can see, it's 2/5. But they have different y-intercepts, okay? All right, so suppose I said something like, here, I want you to find the equation of a line that's parallel to y equal to x minus 3 that contains this point -2, 1. Okay, so I'm going to just take this out so I can look better. Okay, so first of all, because my new line is going to be parallel to this line, the slope of my new line is going to be the same. Okay, so if my original slope is 2, how do we know? That's because it's already in the form y equal mx plus b, and we know that the coefficient of x is the slope, so the coefficient is 2, so there you go. The new slope is going to be exactly the same value. So, okay, so now I have that my slope is 2, and I know that it contains a point -2, 1. So I have a point, and I have the slope. Which formula do you think I need to use? If you said point slope formula, you can give yourself a pat on the back because that's what we're going to use. So y minus y1 is equal to m times the quantity, x minus x1. Okay, what's x1, y1? That's my point. And m is your new slope. So y minus 1 is equal to 2 times the quantity x minus -2. Don't forget your extra parentheses. This becomes a positive. Y minus 1 is equal to distributing the 2. 2x, this is a plus 2, so 2 times 2 is 4 today. And then add 1 to both sides, we get y is equal to 2x plus 5, and we're done. Okay, now, let me say a few words about perpendicular lines. I know we introduced them before, but now we're going to talk about it a little bit more. So observe the following line. Okay, so here we have a line, and it has what slope? It has the slope, let's see, rise over run. So we go up 1, 2, 3, 4. Wait, actually it's shorter. We can go a little bit shorter. If we go up 2 and over 1, notice that the slope of this first line is +2. Now, if I want to draw a perpendicular line to this point, I'm going to use the negative, according to theory, right? The slope of the perpendicular line to the original line is going to be the negative reciprocal of the first, right? Remember that the slopes are negative reciprocals. In other words, you just take the reciprocal of the first number and then add a negative. So let's test that. Okay, so if this is a -1/2, it goes down 1 over 2, right? Down 1 spot, to the right 2. Okay, we make it up, down 1 over 2. Okay, let's draw this. And notice, look at it, they make a perfectly right angle with each other. So that's, they're perpendicular. Two lines that cross on the same plane at 90 degrees, okay? Okay, so what if I want to find the equation of a line perpendicular to another one? We first find the original slope, then find the negative reciprocal. That's going to be the slope of your new line, and then use whatever point you have. So here, we have our original slope is 2. So my new slope, my slope of the perpendicular line is going to be -1/2, okay? And it's going to contain this point 2, 1. So now I have my new slope and a point slope formula. Y minus y1 is equal to m times the quantity x minus x1. So y minus 1 is equal to -1/2 times x minus a -2, which is x plus 2. Okay, distributing y minus 1 is equal to -1/2 x minus 1. 1/2 of 2 is 1 today. So you add 1 to both sides, and you get y is equal to -1/2 x because these cancel out. All right. Let's do here. Okay, so what else? A few words about parallel lines. Lines that have different x-intercepts that are vertical, they're both parallel. Same thing with horizontal lines. All horizontal lines are parallel to each other. They just cross at different y values. So let's say here we go, let's say for example, we want to find a line that's perpendicular. Now perpendicular, what's interesting about horizontal and vertical lines, they're perpendicular to each other, okay? If you have a horizontal line, it's exactly perpendicular to a vertical and vice versa. So let's say we want to have a line that's perpendicular to this point, this line here, x = 5, and we want it to contain the point 3, -2, which is right here. Now we're going to go ahead and draw the line so you can see it. It's going to be a horizontal line going this way. Okay, so the equation for that is just y = -2, and that's it. Okay, so let's see here. Find the equation of a line that is perpendicular to the line y = 1. So we know that it's going to be x equals something, and it has to contain this point -5, 1, so x is equal to -5. Okay, so what did we do? We said y = 1. That's right here, and then we wanted to use the point -5, 1. So here's -5, 1. So the line goes through here, and we want it going this way. So that's x = -5. All right, find another one, equation of a line perpendicular to the line y = -5 that contains this point. We look at the x. So since it's perpendicular, it's just x = -4. Okay. All right, so that's it for section 3.3. Good luck, happy studying, and I will see you on the next video.